Good evening, students. Today we are going to discuss in atomic structure molecular orbital theory. Molecular orbital theory. It is very important 5-mark question. First, you have to know what is a molecule. First of all, you have to know what is atom. What is atom? Atom is the smallest particle of an element. So, what is molecule? Two atoms combined to form a molecule. For example, oxygen is one of the atom. This is another oxygen atom. Now, these two oxygen atoms are combined to form oxygen molecule. So, how molecule form? Two atoms combined to form a molecule. Okay, now we are going to discuss molecular orbital. In a molecule, the first point, in a molecule, electrons are present in new orbital are known as molecular orbital. Electrons are present in new orbital are known as molecular orbital. Just we will see an example. This is one orbital like 1s orbital. This is another 1s orbital. Now these two atomic orbitals going to combine to form a molecular orbital. Now electrons are entered in this new orbital. For example, here you have two electrons. This another orbital have two electrons. This is what, for example, 1s. 1s. Now, these two atomic orbitals going to combine to form a molecular orbital. Okay. So, what is first point? In a molecule, electrons present in new orbital. Now, you totally have 4 electrons. Now, these 4 electrons going to enter first bonding level, then anti-bonding level. So, what is first point? In a molecule, electrons present in new orbital are known as molecular orbital. So, now this is only molecular orbital. This is atomic orbital. This is only molecular orbital. So, in a molecule, electrons present in new orbital are known as molecular orbital. How molecular orbital will form? Now, combination of two atomic orbitals. So, the molecular orbital is formed by combination of two atomic orbitals. These molecular orbitals, how it will form? It must be both are have same energy or comparable energy. Then only molecular orbital will form. Then, whenever this molecular orbital will form, that time one is getting lower energy named as bonding molecular orbital. Another one is getting higher energy named as anti-bonding molecular orbital. So, whenever two atomic orbitals combine to form a molecular orbital, that time one is getting lower energy named as bonding molecular orbital. Another one is getting higher energy named as anti-bonding molecular orbital. Next point, the shape of the molecular orbital is depends upon the shape of the combining atomic orbitals. Yes, because for example, புளிய விதை போட்டா புளிய மரம் தான் முளைக்கும், மாமரம் முளைக்குமா? முளைக்கவே முளைக்காது. It's highly impossible. So the shape of the molecular orbital depends upon the shape of the combining atomic orbital. Okay. Now this molecular orbital, this is the bonding level. These are lower energy, anti-bonding are higher energy. Now these bonding molecular orbitals are denoted by sigma or pi or delta. Anti-bonding molecular orbitals are denoted by respective stars. Sigma star, pi star, delta star, like that. For example, this is sigma star. This is this bonding level, no, sigma. This is sigma star, right? Then 3 rules. What is Hund's rule? According to Hund's rule, no pairing occurs until all the orbitals are singly occupied. That means, you know what is the p orbital? For example, p orbital split into 3 types: px, py, pz. Px, py, pz. Suppose you have 4 electrons. You can't fill like that, 2 electrons, according to Hund's rule. So, what is Hund's rule? According to Hund's rule, you have to fill all the orbitals first singly. Then only you have to fill doubly. So, what is Hund's rule? No pairing occurs when until all the orbitals are singly occupied. So, you have to fill first. Suppose you have 4 electrons, means you have to fill 1, 1, 1. Now, all the orbitals are singly occupied. Then only you can fill doubly, pairly. This is Hund's rule. So, no pairing occurs until all the orbitals are singly occupied. The next one is the Pauli's exclusion principle. According to this principle, all four quantum numbers are not same. All four quantum numbers already you learned in 11th standard. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Maybe all the three quantum may be same. Principal, azimuthal, magnetic, all are same. But spin not the same. Spin mean one is upward, another one is downward. Must be opposite, plus and minus. So all four quantum numbers are not same. That only Pauli's exclusion principle. Another one is half-pass principle. According to half-pass principle, when you are writing electronic configuration, all the electrons enters in increasing energy level. According to half-pass principle, electrons are filled in there according to increasing energy level. So you have to write all the 8 points. Exam point of view, they are asking only 5 points. Explain any 5 points in molecular orbital theory. So according to molecular orbital theory, what is first point? In the molecule, electrons present in new orbital are known as, in the molecule, electrons present in new orbital are known as molecular orbital. The molecular orbital is combination of two atomic orbitals. Combination of two atomic orbitals. The number of molecular orbital is equal to the number of combining atomic orbitals. Whenever the molecular orbital is formed, that time one is getting lower energy called as bonding molecular orbital, another one is getting higher energy named as anti-bonding molecular orbital. Always this bonding molecular orbital is denoted by sigma, pi, delta. Respective anti-bonding molecular orbitals are represented by sigma star, pi star, delta star. Then these three rules. What is Hund's rule? No pairing occurs until all the orbitals are singly occupied. Pauli's principle means are not four quantum numbers are not same. Then last principle is half-pass principle. The electrons are filled in increasing energy level. You have to write at least 5 points. Very important 5-mark question. The next 3-mark question. What is bond order? MO theory is over. Then what is bond order? Actually, what is bond order? For example, oxygen, oxygen, you can write double bond. Hydrogen, hydrogen, that is single bond. Nitrogen, nitrogen, that means triple bond. What is bond order here means? This is bond order. In between the atoms, you are putting a bond, no? That is what? Bond order. For hydrogen molecule, bond order 1. Oxygen molecule, bond order 2. For nitrogen, bond order 3. Commonly, bond order increases, bond length decreases. That means, see here, hydrogen, hydrogen, bond order this much. Then oxygen, oxygen, somewhat less. Nitrogen, nitrogen, very less. See here, bond order is 1. Bond order 2, bond order 3. So bond order increases, bond length decreases. So what is bond order? What is bond order? Bond order may be defined as half the difference between number of electrons present in bonding molecular orbital and number of electrons present in anti-bonding molecular orbital. So bond order is equal to half the difference between number of electrons present in bonding molecular orbital and the number of electrons present in anti-bonding molecular orbital. Simply you can write like this, Nb minus Na by 2. This is bond order. So bond order of oxygen molecule is 2. 1 mark question, very important 1 mark question. What is bond order of oxygen molecule? 2. Hydrogen molecule 3. Commonly bond order increases, bond length decreases. Okay, the next 3 mark question. Very important 3 mark. Why helium-2 is not exist? We can always see that H2, O2, N2, likewise. But we never seen He2 because helium is an inert gas. The question is why helium-2 is not exist? Why helium-2 is not exist? Any idea why helium does not exist? Because bond order is 0. First, you have to write all those things. Here, helium, the atomic number, that means Z is 2. 2 means, what is the electronic configuration? 1s2. 1s2 is the electronic configuration. Okay. According to MO theory, electronic configuration for helium molecule, that means helium 2, sigma 1s 2, sigma star 1s2. I'll explain how to write electronic configuration. So how to draw the MO diagram? How to draw the MO diagram for helium molecule? Listen, this is the energy level, because according to Alpha principle, electrons are filled in increasing energy level, so that arrow mark is upward. This is what? Energy. Okay. So helium, no, atomic number 2. That means 1s. Okay. This is the 1 orbital, 1s orbital. Helium, if you have 2 electrons, so you are going to write 2 electrons. This is one helium atom. This is another helium atom. So from another helium, another 1s orbital. That 1s also have 2 electrons. Now these 2 helium atoms going to combine to form a helium molecule. So nothing but He2. This is what? Atomic orbital. This is also atomic orbital, but going to form a molecular orbital. Okay, now these 2 atomic orbitals are going to combine molecular orbital. So then one is getting lower energy, named as bonding molecular orbital. Another one is getting higher energy, named as, this is the bonding, this is anti-bonding molecular orbital. So namely you can tell sigma 1s, this is sigma star, because anti-bonding, sigma star 1s. Totally we have 2 electrons. So that first you are going to fill the electrons in bonding level. Then if you have extra electron, you are going to fill in anti-bonding level. Now you can write the electronic configuration for this one helium molecule. Helium 2 is equal to sigma 1s. How many electrons? 2 electrons. So you can write sigma 1s 2. Sigma star 1s, how many electrons you have? 2 electrons. So you can write sigma star 1s 2. Sigma 1s 2, sigma star 1s. That is electronic configuration. Now you have to find the bond order for this hydrogen helium molecule. Bond order. You know the formula? Bond order is equal to Nb minus Na by 2. So bond order is equal to, what is the formula? Nb minus Na by 2. What is Nb? Number of electrons present in bonding level. What is bonding? Here only bonding. So bonding level you have 2 electrons. Nb is equal to 2. What is Na? Anti-bonding level. How many electrons you have? 2 electrons. So you are going to write 2 by 2 is equal to 0 by 2 is equal to 0. Bond order 0. Suppose bond order 1 mean at least helium at least 1 will come. 1 mean 2 mean 2 will come. Bond order 0 nothing. Then how helium 2 will form? Because bond order 0, that's why helium 2 is not exist. So how to write first this electronic configuration, then this diagram, bond order, all those things. Very important 3 mark question. The next topic, molecular orbital diagram of nitrogen molecule. For nitrogen molecule, you move diagram for nitrogen molecule. Okay, what is the atomic number, symbol of nitrogen? N. Atomic number of nitrogen? 7. So atomic number 7 means, how to write electronic configuration? That means what? Z is equal to 7. Z is equal to atomic number 7. So electronic configuration 1s2, 2s2, 2p3. 2p3 mean actually what? 1s2, 2s2, 2px1, 2py1, 2pz1. This is electronic configuration. Now I am going to draw the diagram for MO diagram. MO diagram. Here energy level according to Alpha principle, electrons are filled in increasing energy level. So energy, atomic number is 7. So that electronic configuration 1s2, 2s2, 2p3. That means 2px1, 2py1, 2pz1. Normally, when we draw the diagram, we no need to draw for 1s orbital because very lengthy diagram will come. Instead of 1s2, you can represent k, k. K means first two electrons enters in K shell. K shell. That means what? This is a nucleus. This is a first order K shell, L cell, M cell, like that. First two orbital enters in which orbital? This is K shell. So that first K for bonding level, next K for anti-bonding level. When we writing the electronic configuration according to MO theory, no need to draw diagram. Instead of diagram for 1 or 2, you can represent K, K. Okay, we'll start from 2s orbital. 2s orbital. Now see here, this is the one nitrogen atom, this is another nitrogen atom. Now these two are going to form a nitrogen molecule. Nitrogen atom, no, this is what then? Atomic orbital. This is another atomic orbital going to form a molecular orbital. Start from what? 2s. So 2s means how many electrons you have? What? 2 electrons. 2s. You know what is s orbital? Okay. This is what? Which is 2s. 2s. How many electrons you have? 2 electrons you have. Okay. So this is from this nitrogen atom 2s. This is from another energy level. This is another 2s. How many electrons you have? 2 electrons you have. Now these two atomic orbitals are going to combine to form a molecular orbital. Now one is going to get a lower energy named as bonding molecular orbital. Another one is getting higher energy named as anti-bonding molecular orbital. So 2s no, so that sigma 2s. This is sigma star 2s. Totally, you have how many electrons? 4 electrons. So you have to fill first 2 electrons in the bonding level, next 2 electrons in the anti-bonding level. Next one is what after 2s? 2p. Now, this is from p orbitals split into 3 types. What are they? 2px, 2py, 2pz. How many electrons you have? 3 electrons. So each and every orbital 3 electrons. You can't fill directly 2, 1 because according to Hund's rule, you have to fill all the electrons first singly until all the orbitals are singly occupied. So that 1, 2, 3. It's from this nitrogen molecule, nitrogen atom. Another 2p from this nitrogen atom. You have 3 things. So here, which one is 2px? Which one is 2px? Here x, y, z. Here not x. This only 2px. 2px, 2py, 2p. Because they all coming from this side. X, y, z. We have totally 3 electrons. X1, Y1, Z1. Okay. Now, these two atomic orbitals going to combine to form a molecular orbital. Now, this is what pi 2px, pi 2py, sigma 2pz. Is that alone sigma? I mean head to head overlap means sigma bond will come. Sideways overlap means pi bond. Head to head overlap means sigma bond. Sideways overlap means pi bond. So that is that alone sigma, x and y pi bond. Very same thing anti-bonding also. Anti-bonding also first initially 2 things will come. 2 things mean that is pi star 2px, pi star 2py, then sigma star 2pz. What? Sigma star 2pz. Totally how many electrons now? 6 electrons. You have 6 electrons. So first you have to fill bonding level. 1, 2, 3, 4, 5, 6. That's all. Suppose you have extra electron, you can fill in the antibonding level also. But if you have only 6 electrons, all the 6 electrons you filled in the ground state itself. So no problem. Now we are going to write according to MO theory, electronic configuration for this molecule. Which molecule? Nitrogen molecule. According to MO diagram, how to write electronic configuration? Instead of 1s, you can write KK. K indicate K shell. The first 2 electrons end up in K shell. For bonding, it's anti-bonding. Okay, bonding, anti-bonding. But next one, sigma 2s. Sigma 2s. How many electrons is there? It contains 2 electrons. Then what? Sigma star 2s. Sigma star 2s. How many electrons? 2 electrons. Next one, pi 2p x. How many electrons contains? 2 electrons. Then pi 2p y contains 2 electrons. Then sigma 2p z 2 electrons. This is a MO diagram. According to MO diagram, electronic configuration. Now we are going to calculate bond order. You know the formula for bond order? Bond order is equal to what's the formula? NB minus NA by 2. Okay, count and tell me how many atoms, how many electrons present bonding molecule orbital. Just count and tell me. Totally, this is bonding. Now, bonding molecule orbital means this is bonding. This is also bonding only. So that here you have 2 electrons. Here 6 electrons. Altogether 8 electrons. All no need to indicate. So that for bonding, here totally you have 8 electrons. In antibonding, how many electrons you have? Only 2 electrons. Only 2 electrons. So that antibonding level 2 by 2. What's the answer? 6 by 2 is equal to 3. So what is bond order? Bond order is equal to 3. Bond order is equal to 3. That indicate what? Nitrogen bond order is what? 3. So what is nature of bond? Nature of bond is triple bond. Nature of bond is what? Triple bond. Because bond order 3, so that nitrogen bond order 3, nature of bond is triple bond. Then they will ask question, this is whether diamagnetism or paramagnetism. Whether it is diamagnetism or paramagnetism. How to find? You have to see this full molecular orbital. No need to see atomic orbital. Only molecular orbital. See, all the electrons are paired or unpaired. You know what you mean pair or unpaired? Like this means this is unpaired. This like this means paired. You have to see whole molecular orbital whether all the electrons are paired or unpaired. See, paired, paired, paired. Everything paired. Paired. So that this is magnetism is, that means magnetic character. Magnetic character. See here, all the electrons are like this. Unpaired means that is paramagnetism. All the electrons like this paired means that is called diamagnetism. So any compound contain one single electron. Unpaired electron means that is a paramagnetism. Paired means diamagnetism. See here, everything is paired. So that nitrogen molecule is magnetism, diamagnetism. Able to understand? So first nitrogen atomic number is 7. So electronic configuration 1s2, 2s2, 2p3. 2p3 means 2px1, 2py1, 2pz1. So first we are going to draw the diagram, energy level diagram. According to Ahm's principle, electrons are filled in increasing energy level. So energies are going upward, increasing energy level. No need to draw diagram for 1s level because very lengthy diagram will come. That only instead of 1s only you are putting kk. 2s. For this nitrogen atom, that's a 2s. For another nitrogen atom also is that because 2 nitrogen atom going to combine to form a molecule. Now this 2s for that nitrogen, Now these two 2s orbitals are going to combine. That is, one is getting lower energy named as bonding molecule orbital. Another one is getting higher energy named as anti-bonding molecule orbital. So bonding means sigma 2s, anti-bonding means sigma star 2s. Then 2p. 2p is split into three types: 2px, y, z. Likewise 2px, y, z. Now these two atomic orbitals are going to combine to form a molecular orbital. That time z mean head to head overlap, so that is sigma, that is x and y are pi. This is the pi 2px, pi 2py, sigma 2pz. Totally you have 3 plus 3, 6 electrons. So first you have to fill bonding level, then only anti-bonding level. You have only 6 electrons, all the 6 electrons filled in ground state itself, in bonding state itself. So no need to indicate in the anti-bonding level. Now we are going to write a more electronic configuration. Instead of 1s kk for bonding anti-bonding, then sigma star to sigma 2s 2 electron, sigma star 2s 2 electron, pi 2px 2 electron, pi 2py 2 electron, pi 2pz 2 electron. No electrons in anti-bonding level, so no need to indicate. Then you have to count the bond order. Bond order is equal to formula Nb minus Na by 2. Nb means number of electrons in bonding molecule orbital. How many electrons is there? 2 plus 6, 8. So that 8. Number of electrons in anti-bonding molecule orbital. 2 plus nothing 0. So that 2. So 8 minus 2, 6. According to formula, 6 by 2 is equal to 3. So bond order is equal to 3. So that nitrogen bond order 3. So the nature of bond is triple bond. Nature of bond is triple bond. So magnetism, diamagnetism. Why diamagnetism? Because no unpaired electrons, everything is paired. Paired means diamagnetism. That's all very important, easiest 5 mark.